Hello and welcome to the lecture today. We have introduced the use of lists, tuples, and sets in the previous two lectures. And it's been a really general overview of those type of elements. And what we're going to do in this lecture is continue with the same topics, expanding on the uses of lists and tuples and strings also, and seeing some of the manipulations that we can do with those kind of data types. So I'd like to review a little bit about what we've done so far. So we call this different data types containers because each one contains the data associated with your program. So in the Python jargon, they're called containers, okay? And so we have in Python 5 different types of containers. The string, as we know, a string can hold a sequence of characters or a single character as well. And it cannot be modified after it's being created. So it's immutable. And we call it immutable because it cannot be modified. A list can hold any other set of sets of all data types in Python, including other lists. And the elements in the list can be modified after creation. So we call those mutable containers. A tuple is very similar to a list, but the elements in tuple cannot be modified after we create them. The same thing happened with strings. The strings cannot be modified also, as we mentioned just now. And a dictionary, which is a very, very efficient method to form mappings from a set of numbers, and is a very sophisticated way of manipulating large sets of data. And then the set is equivalent to the set in mathematics, except that in the case of Python, there's no order in the elements, and there's also no indexing supported. Lists and tuples support indexing, so we can access information in lists and in tuples, as we remember from the previous two lectures, by identifying the index and getting to the data that way. So those are the 5 types of containers that we have in Python. Okay. So as we mentioned before, there's an element of the immutable or immutable, and we've got to look at this also again. But also it's common to refer to the strings, the list, and the tuples as sequential containers, or simply S containers. And for obvious reasons, they're called sequential containers because the sequence of elements that each one has is important in manipulating the data. So we call the string, the list, and the tuple the S-type containers. So in most cases, you'll see in one of the books in this lecture, we'll be referring to S containers for this group. They consist of consecutive elements indexed by integer values, and as you remember, we start always at 0. Dictionary, on the other hand, is not sequential, and the elements indexes are arbitrary. We'll see a little bit of this later in the course, but our focus for now is going to be mainly on the S container types. Some container types are also called created frozen, which is another way of saying they're immutable. After creating them, you can wholly destroy them, but you cannot change or delete the individual elements, and that's what we call immutability. Strings and tuples are immutable, and lists, dictionaries, and sets are mutable. Okay, they can be changed after they have been created. This may seem like a contradiction because if you create a list, in many instances, you're going to have to add something to it or delete something from it. And there are ways of doing that, okay? But it's not immediately done through indexing, as you'll see later. And with a mutable container, adding new elements and changing or deleting existing ones is possible. So all containers except the set have the individual. You can find the individual elements by an indexing method using brackets in the case of lists, and we use parentheses in the case of tuples. For the S containers, the index is just a number where counting starts with 0, and a negative index used only on, again, on the S container types, strings, lists, and tuples. The negative index has a meaning that the counting value is relative to the n. So in this example that we have here on the screen, we have a list of elements. We have 6 elements, each identified by a string, right? And so by using this notation, the -1 indicates that we are accessing the last element on the list. Okay, so the last element on the list has as a reference this index value -1. And the second from last element, which will be accessed by typing a -2 inside the brackets, will obviously be associated with the element white in the list. In the same way, if we go back, right, this element, as you can see, has 6 elements in it. This list has 6 elements in it. So addressing color -6 in brackets means that you actually going back. If this is the last one, -1, -2, -3, 4, 5, and 6, it's actually addressing the first element on the list. So this means that we can access elements on the list by either using positive indexes or negative indexes. They're both really useful depending on the situation. Okay. So as we saw, indexing allows you to access, to change, delete only a single cell of a list, or a group of elements on the list. What if you want to get a sublist of a list, for example? We want to update a bunch of cells all at once, or we want to extend the list with, you know, an arbitrary number of new cells in any position. Well, those are the things that will be important for us to know how to do, how to manipulate lists and strings also, so that we can add elements, we can delete elements, we can move elements around, and that kind of operation. So we're going to do that in the next few slides that we have here. So one of the things that we can do to manipulate lists or S containers, as we call them, the entire group, is that we can use slicing. And slicing allows S containers to access multiple elements at once. You can define a start, an end index, and obtain the portion that lies in between the list or the S container. The element of the start index is the first to be accessed. The end index is where accessing stops. The element of the end index is not accessed. That's one of the things we need to be a little careful about, that, because even though we have to indicate it, that end index is not actually accessible when you note it in the command. And so the end index is not inclusive, okay? And we'll see examples of that in just a minute. It's also possible to define an increment, a jump amount between indexes. After the element at start is accessed first, then if you put an increment on it, then the start plus increment is accessed next. And this goes on until the access position is equal or greater than the end index. And we'll see examples of this in just a minute. For negative indexing is a little more challenging, and you're probably going to have to practice this a little more so that you can get used to negative index. But for negative indexing, a negative increment has to work from the bigger index towards the lesser, so that the start index is greater than the end index. And you'll see how this works in several examples we'll do in just a few minutes. But also, all this that you had on this slide here can be described by looking at a picture here. It will be better than the way that this describes it. And in the picture, you can see that this black circle represents the container. And again, it could be a string, a list, or a tuple. Yeah, so this applies to any of those types. And what it means is that in between columns, we're going to have the index that starts the slicing, or in other words, the first element in the slicing. And on the second, after the first column, we have the stop index. So the information will then be extracted from whatever this number is, and it'll stop at this point. And remember, it is not inclusive, okay, as we'll see later. So this element, we have to put it in place, but it won't be the one that will be accessed or be displayed last. And then the third one is optional, and it's called the index increment. If we leave that blank with no number in it, by default, it's going to just increment by 1 every time. If we leave the first element empty, then it means that we start at 0. Okay, and if we leave the stop index also empty, it means that we're going to just keep indexing one element at a time. So remember that if you don't see a number associated with any of these indexes, remember what that means. If it's empty, it means that we start at the index 0. If this middle one is empty, it means that it's just going to keep going one element at a time. And if this one is also empty, the last one, the slice, the index increment, it means that that it's going to increment by 1. Okay. All right. So that's what we define as the starting index, the ending index, and the index increment between elements. So that's the notation that this describes. If the S container is immutable, that is, if it has a string and tuple containers, then slicing simply creates a copy of the sliced data. Otherwise, if the S container is mutable, that is like the list container, then slicing provides direct access to the original elements, and they can be updated, which updates the original container. And we'll see examples of this next. So for example, and I'm going to be using this list called nums in several of the examples in this lesson. So we're going to keep referring back to this list several times just to make things easier to understand. So we want to take a sub list from this num list. What do we do? Well, one way we can do, if you look at this notation here, if we say, well, nums in brackets 2 colon 7, the one this means again is that we have a starting index of 2, right? And we have a stop index of 7, okay? And the increment is not indicated, so the increment will be 1. So we're going to go 1 at a time, right? So that means that we're going to start index element 2, and if you remember, the index starts at 0. So index 0 means that it includes this element 10. So index 1 is 20, index 2 is 30 in this case. So that means, again, that this command will display the element in index 2 for nums, starting at element 2, so will be 30, and it'll increment by 1 because the increment is not indicated, so automatically increment by 1, and it's going to stop at element 7. Okay, so again, remember we have in this case, we have 9 elements right here, right? So the elements by themselves are going to be counted, like they are on the list. So we have 9 elements here, right? So that means that this command will return up to the element previously to 80, which in this case will be 70, right? So we go 0, 1, 2, 3, 4, 5, 6, 7. But 7 won't be included on this list. It just says that this is where we're going to stop, but the one previous to that is the one that's going to be extracted from this list. Okay, so that's what that means. You can see also this here, how this is done graphically. The only exception here is that in this example this graphic that you see here, the result of num 2 column 7 was placed on this other variable called sum nums, okay? Which we didn't show that in here, but that's what this is happening here. Is extracting from nums, which goes from the numbers in decades 10 to 90, to another variable called sum nums by using this command. As you can see here, again, you start at index 2, right? And you're going to stop, it says to stop at 7, right? Index 7, but index 7, the element in index 7 is not going to be included, but the one previous to that will be. Okay? And that's what you'll see here as a result of running that command. Also, you notice here on the right, if we run nums 0, 5, as you can probably imagine, it will go from element 0 through 1, 2, 3, 4, 5, right? 5 will be here, right? So you only will see from 10 to 50 by running this command. Also notice that if you expand the ending or the stop beyond the number of elements on the list, it'll just assume that you're looking for till the end. So in this case, even though we only have 9 elements, if you do 4 column 10, it's going to start element 4, right? 0, 1, 2, 3, 4, which is 50. And then saying that to stop at 10, even though we don't have 10, it's just going to ignore anything after 9. And it's going to give you whatever that is after this 4th index element. The same thing here, you notice here that if you put a 12, it's just going to ignore the rest. It's just going to go to the end and give you everything that is on the list after the element 4 in this case. So as you can see, this command and this command doesn't make a difference in this case. There's also a shortcut way of accessing the information that you can have if we ignore or if we don't have anything on the first index element, okay? Then it simply means, remember that we're going to start index 0, okay? So, so this notation here at the bottom with no index element column 5 is exactly the same thing as this, okay? It's just a shortcut way of not displaying that information, okay? They're equivalent. All right. Okay, looking again at the same list of numbers that we have, we can do some operations, right, to start seeing how we can manipulate elements on the list. For example, we can look at taking n last elements of a list, and for that, we're going to use negative indexing. Okay. For example, if you look at this command here, nums -3 column, nothing after that, then what we're saying is that we're looking at the third element from the end. So this is the first one, this is the second one, this is the third one. So it's the third element from the end on. And as you can see here, the stop parameter is skipped, right? We don't have a stop parameter here. And we don't have an increment parameter index either, right? So that means that you take from the start position till the end of the list, right? So you go from this, right, from this element, which is the third. It says start at the third element from the end, and then keep going to hit the end of the list. So we start from the third element, from the end value, from the end, which is 70 with index -3, and then take everything to the end. Okay. So that's one use of negative indexing. A couple of examples. If we look at this one here, nums 1 column -1, it says that the start index is 1 and the stop index is -1. And again, we're incrementing one element at a time because it's not display. So, so as you can see here, we started at index 1, which is this one, right? And so what that's saying is that we're just going to the end, right? And in this case, since the stop, remember, brings us to, it indicates that the element we're going to see is going to be one less than this last index, right? So that means that we're going to go from element 1, which is 20, towards the last element, right? But remember, the last element is not inclusive, so we're not going to display that element. We're going to display the one just before that, which in this case is 80. That's what that is, and that's what you see here. So make sure that you understand that notation and what that is telling you as far as extracting the information. Another example, in this case, the start index is -3 and the stop index is 8. So what that means is that we're going to start again, we're going to start element -1, -2, -3 is 70, right? And it says stop at element 8, right? So in that case, is we're already starting at -3. This element here, or this command here, will show 70, 80 as the elements you're extracting. Another example, in this one, the starting index is -5. So again, you go -1, 2, 3, 4, 5. It brings you here. And then the stop index is -1. So what that means is that, again, it's going to bring you to, that end here, just like in this first case here. So it's going to go from 50 to 80 in this case. Okay. Some more examples. In this case, we're going to take a look at taking all but the n last elements of the list and how we can do that. Again, we have the same nums list example that we had before. And if we run this command here, we want to take all but the n elements of the list, we can run this type of commands. For example, in this case, we have a starting index of 0, right? Because it's not indicated, so that means that we're going to start at 0. And then we're going to increment, or rather, we're going to stop at element -2, and the increment again is 1, right? So element -2 will be this one here, right? So that means since that one is not inclusive, then the last element we're going to see is 70. So this command here brings us from element index 0, which is 10, and then it's going to increment one element at a time until it hits -2, but this is -2, which will not be included, so we'll see 70 here. So we take all but the last two elements of the original list, as you can see, right? All but the two elements of the original list are included by this command. Some of the other things we can do is take in every nth element of a list. And this is another case here. This is using an index increment of 2. The starting and the stopping indexes are not indicated, so we know that by default the starting index is going to be 1 or 0 rather, the first element, and then it's just going to go one element at a time, it's going to stop towards until the end because there's nothing indicated here. And then the 2 indicates that it's going to be every second element is going to be extracted because the increment is 2. So starts at 0 by default, index 0, right? We know we're going to stop until we see the end of the list because there's nothing indicated here. So the other thing that we know is that because the increment here is 2, is that we're going to skip every other element, right? So we're going to 10, 30, 50, 70, 90, and that's it. That's what you'll see here by this command. Also, if we provide the starting index, we can skip some element, right? So if instead we say, well, start at 1, index 1, which is 20 in this case, contains element 20. And again, we're gonna go every other element because the index increment is 2. So you go 20, 40, 60, 80, and that's it. Because the next one, we don't have another 10th element here. So all you'll see will be 20, 40, 60, 80 when you run this command. Okay. Another way also, let's say that we don't want to include some element at the end, we can add the stop parameter, right? So in this case, we have all of the parameters here. We have all the indexes. So we have a start index, we have a stop index, and we have an increment, right? So again, we're going to start at index 1. Index 1 contains 20. And then we're going to go 2 elements again at a time. Right? So we're going to go 20, 40, 60, but we're going to stop there because that's what stopping index says, to stop at -3, which is right here, right? And again, remember, since it's not inclusive, we're not seeing it, right? So we're only going to see 20, 40, 60 by running this command. So this is something you can do in Spider or just to test. There are many other ways or examples also related to this, and I encourage you to try them yourself. Maybe come up with some of your own and try to guess what the answer is going to be. So again, this takes practice to get used to it. All right, the next one we're going to see is using negative step in reverse lists. Okay, again, this is our list that we'll be using so far, and notice that if before we look at the negative index increment index here, notice that if we just simply don't have any numbers right inside the brackets here, and all we have is just the column, then that means that we have all the default indexes types, right? So that means that the first index is going to be 10, then we're going to run till the last element on the list, and the increment is 1. So this here, this command is simply replicating what's on the list, right? So I hope that that gives you more clarification on the use of indexing, and that you can start, getting familiar with that kind of notation, right? So by default, the first element will be the 0 element or the 0 index, which is 10. It's going to run till the end by default because there's nothing in here, and the increment is 1. So what we see is that we see all the elements of the original nums list. In this case now, if we use a negative step, then what we'll get is a reverse list, right? Again, we're going to start at first element. We're going to increment until we get to the end of the list, but instead of starting at, like in this first case, we start at element, or rather the increment is 1, right? This one here tells us that we're going to start at the end, right? So we're going to start at 90, or the element 90, and then go backwards, right, towards the left. So negative step changes the way slice notation works. It makes the slice be built from the tail of the list. So it goes from the last element to the first element. That's what we get our reverse list with a negative step. So negative stepping is different, as you can see. Positive stepping, right? It means that we're going forward from left to right. But negative stepping means that we go backwards, right, from right to left. So again, that's part of getting used to the notation here. Is a little strange, but it gets some getting used to in order to use it. So let's look at more examples here. Using negative step and reverse list. Again, we have the same list, and as we mentioned just now, negative steps turns everything upside down, basically. Due to the previous peculiarity that we just noticed, start and stop when using negative steps, start and stop should be provided from right to left as well. For example, if you want to have a reverse list, which starts from 80, so if we want to go from 80, given this list, we're going to start from this element 80, and then we're going to go back until the first element. We can then start at the last second element from last, right? The second element from last is this one, 80. And then we're going to then just go round out to the end of the list because we have nothing here. But then the increment is -1, which means that we're going backwards, right? So we're starting at 80, and then we go one element at a time, but in the other direction. So we start from the second, or from the -2 index element, which has a value of 80, and go from right to left, collecting all the elements in the reverse list. Okay, so again, make sure you understand how this command results in this output here. We can use stop value to stop taking before some elements. For example, if we don't want to include 20 and 10, like if we have this list and we want to exclude the 10 and the 20, in this case here, the difference will be that we're going to stop at element or index 1, right? So if we include that here, it means that you're going to stop at element 1. So we use 1 for the stop index, which is the element with the value 20. So we go from 80 till 30, not including the value of 20 in that case, right? So we go, the first element here is not going to change. It's going to be 80, right? And we know we're going to be going backwards because this is -1. So we're going to go from right to left. But it tells us to stop when we get to index 1, which is 20 here. And again, since 20 is not inclusive, what we'll see is just 30 here. Okay. So with a negative step, the stop index is located before the start. That's really what this indicates here. All right. More on reverse lists, negative steps. Again, let's go back to the nums list. And notice the differences here, right? Let's say that I just want to, if I do start index 2, and I'm going to run till the end, right? Because I don't have anything in the middle here. And the index is going to be 1. So this simply, again, tells you that you start at 2, index 2. The starting index is inclusive, okay? So that includes 30 here. So that simply means I'm going to go one at a time until I hit the end of the list. So we'll go from 30 to 90 here. So all the elements is starting with the index at index 2. This one, on the other hand, if I made this a minus, then I'm going on the other side, right? That means that I'm starting at the second element from the last, right? This is the first element from the end, right? -1. This is the second element from the end. So it's 80. And I'm going to go forward one step from right to left until I hit the end, right? So, and again, since I'm going forward, because now this index is positive, right? I'm starting here, but since the index, the increment is positive, it's a +1, I'm going from left to right. So the next one is just going to be 90. So I'm going from the second element from the last till the end, and the end is just 90. Okay, so see the difference here between this and this, right? And the use of negative elements and what that means. When they're used as starting index, right? It is going to put you here or here, right? When you start, right? And when you use it as an increment, then it's a positive, it's going to move you forward from left to right. But if it's negative, the index increment, it's going to move you or the elements from right to left. Okay, that's the difference, really. Another example, if we look at this one here, nums bracket -2, column -1. That means again that we're going to start at index 2 from the end, which again is 80. Okay, and we're going to hit until we hit the end of the list, right? Because there's nothing here. But again, this time we're going with a negative increment, which means that we're going from right to left, right? And we're going to stop at the last element. So we're going to start from 80, going all the way down to 10. Okay, as opposed to this one here that starts at 80 also, but it goes towards the right. See the difference between these two, right? This one starts, they're both statements, they're both commands, start the index at -2. They both start right here, these two commands. The first one brings you towards the right, but this one brings you towards the left. Okay, because of the index increment being negative. Another quick example, applying the same idea here, is if you look at nums -2, column -2. The only difference between this and the previous one we just did is this -2 now. So in this case, if you remember, we know we're going to go from right to left, in this case, one element at a time. And on this one, it's just saying the same thing. You're going to go from right to left, starting at 80, but this time, 2 elements at a time, right? So again, we'll start here, and then we're going to go 60. So it's at 80, 60, 40, 20, and that's it. That's what you see here. Okay, so that's the use of negative indexing. Okay, it's very useful, but it's a little tricky sometimes, and you have to get used to it in order to feel comfortable using it. All right, let's look at now slicing and copying. One important thing to notice is that list slice creates a shallow copy of the initial list. That means that we can safely modify the new list and it will not affect the original one. So if, for example, looking again our previous list that we've been using so far for nums, I'm going to create a new variable called fst_5, first 5 numbers. And what it's simply doing is extracting from nums the elements starting at index 0, okay, up to element 5, which in this case, it'll go 0, 1, 2, 3, 4, 5. But as you know by now, this 5th element is not going to be included, but this one will be 50. So what this simply is doing is extracting from nums, nums is this variable here, the elements from 10 to 50, which is what you see here, right? Now, if you take this new variable, fst_5, and then I place a number 3 in index 2, then I'm modifying the original nums list, right? Because what I'm doing now, I'm placing a modified list, right? From FST5, which, as you remember, this statement here, the first one simply puts the number 10, 20, 30, 40, 50 into FST5, but now I'm saying I'm going to replace or place the number 3 at index 2, okay? So instead of seeing 10, 20, 30, 40, 50, this 30 is replaced by 3. And then this new variable will look like this. But as we mentioned previously at the beginning, this is not modifying nums, okay? Obviously, because we are basically saving the changes into a new variable, and we simply using nums to copy a sublist into a new variable here. And the sublist we can then modify, okay? There's also a shortest form of slice notation if we just use columns like this, nums column. For example, if I say nums in brackets column and put that information into, or that content into a new variable called nums copy, okay? This statement here creates just simply a shallow copy of the whole list, and is a good shorthand when you need a quick copy of an original list. So by the end of the day, at the end of this statement, rather, this statement here, nums has this information, and nums copy has an exact copy of the original list, okay? So the original list nums is not going to be affected. I'm just putting that the contents into nums underscore copy. And what I'm going to do now is I am going to modify nums copy, because I'm going to put the number 33 in the location of index 0. So what that means is that, as you remember from here, this is the original nums list. The first element, which is index 0, has a number 10. But in the copy of nums, I'm going to put a 33 in that index location. So that's exactly what this does, as you can see. So when I run these two commands, nums didn't get modified. Nums is still the original nums. But nums copy now has a the first index 0 element modified to include 33 instead of 10. Okay, and that's how you can modify lists. So all the things we can do is we can substitute part of a list. Again, we go back to our nums list here. And by running this command, okay, I'm going to take the numbers 1 through 4, and I'm going to replace the first 4 elements of num, okay? So I'm taking, I'm taking the numbers in nums from index 0 to index, to the stop index. In the case, the stop index is 4. So I'm going to go 0, 1, 2, 3, 4, right? But I'm going to stop, I'm going to get up to 40 here, right? Remember, because this is the stopping point, right? 50. So that means that I'm going to replace these 4 elements, 10, 20, 30, 40, by 1, 2, 3, 4. So when I run this command, nums now looks like this, with the 4 first elements, right? From index 0 to index 1, oops, sorry. index 0 to 1, 2, 3, because 4 is not going to be actually included, is going to be replaced by the new numbers in nums here, 1, 2, 3, 4. Okay. So again, this simple command is replacing the first 4 elements of this list. I can also replace and resize part of the list. Again, if you go back to the original nums, okay, if I simply do a 1 here instead of 1, 2, 4, I'm simply going to replace every number from 0, index 0 to index 4 minus 1, right? I'm going to replace everything by 1 simply, okay? Because I'm only indicating 1. So all of those elements on the original list, in other words, 10, 20, 30, and 40, they're all replaced by one single number 1, as you can see here, okay? So this replaces the first 4 elements of num with 1, okay? It doesn't place a 1 on each of those locations, as you can see, and as you notice here, but it simply replaces everything by just 1. If I want to put individual numbers, I will do this, as you can see here, right? Separated by commas. Okay, another example, using again, going back to our original nums list, what I was telling you before. But in this case, I'm going to replace every other value with 1, okay? So according to our notation, right, I'm going to start index 0, and then I'm going to run till the end. I'm going to stop until I see the end of the list. But every other element, every second element, I'm going to put a 1 in, okay? So again, start at 0, right? Excuse me. And I'm going to replace that first element by 1, then I'm going to skip 1, and then the third one I replace by 1. I'm going to skip 40. I'm going to replace 50 by 1. I'm going to skip 60. I'm going to replace 70 by 1. I'm going to skip 80, and I'm going to replace 90 by 1. Okay, see that? Okay. Notice the difference if I use, instead of using an increment of 2 positive, I use a negative 2, okay? And since I'm using a negative 2, then as you probably remember, we use a negative step, so I'm going to go in the other direction, right? So again, what that means is that I'm going to replace starting at, in this case, with 5, right? Because that's going to be the first one, because I'm going in the negative direction. So I'm going to replace 10 by 5. 20 remains the same because I'm skipping right every other one. Then 30 is replaced by 4. I'm going to keep 40. 50 is replaced by 3. I'm going to keep 60. So 70 is replaced by 2. I'm going to keep 80, and 90 is replaced by 1. So you notice the difference is it happens that way because I'm going with a negative sign here, negative index. That brings me in the other direction, right? And this was going in the positive direction. So notice also that if we have this statement here, nums column minus 2, and I just, in other words, if I just want to display that information, right? I'm not placing anything in nums. I'm not replacing nums like I'm doing here. I just want to see what this will give me. If you remember, this is just reversing the order, right? So this will bring me, starting, from the beginning to the end of the index, but with a negative index of -2, which means that I'm going to start on this side, right? So again, that simply means that I'm going to go every other element starting at 90, right? But starting from the right-hand side, because this is negative. So this will be 90, 70, 50, 30, 10. So See the difference here, right? Right. So this is basically what I'm doing here, except that in this case, I'm placing numbers in those areas, right? Where I had those indexes starting from this side. Also, if you remember, if I do this, so they can, this might help you, try to figure out how this is being done. But if you remember, we did this before, right? If I write this statement here, it simply means that I'm going to access the number in reverse order, right? Starting from the n element, I'm going to go from right to left, right? If I do this. And just to show you the the opposite, if you will, or what happens if this is positive, if this index increment is positive, then it simply means that I'm just accessing, the one here is like if there wasn't anything in there, right? The one, if I didn't have anything, it's by default it's going to be 1. So doing this nums column 1 simply means that I'm accessing every element of the nums list, starting at index 0 and going one by one till the end. However, if I do it this way, right, with the -1, I'm reversing the order, right? Starting from the last element, I'm still going an element at a time, and I'm going to stop until I see the end, but I'm starting again from the last one, from right to left. So you can use this analogy here, this example, if you're having trouble understanding how we're getting these results here with the negative indexing. Okay, some other useful operations common to containers. Again, we're going to use nums as our example here as the list. The first one is the number of elements. If you want to know what the number of elements are on the list, we can use this built-in command or built-in function len, with parentheses. And this function returns the count of elements in the container and that is given as an argument to it. So for example, this is our nums list, right? If we use len parentheses in the name of the variable, then we get the size or the number of elements in the nums list, as you can see. This is another example with a string, and of course it's asking, length. This is a string, so length will return the size of that string or the length of the string. If you notice here, it includes the spaces. So all the characters plus the spaces is equivalent to a length of 16. Another example with a string here, from 1 through 5, as you can see, the length will be 5, right? So that's another useful function. Some of the other things that we can do is concatenation to join lists together. String, tuple, and list data types can be combined, can be concatenated using the plus operation. So it's simple. If we have one container and we add the plus to another container, then it joins the two into a new container that includes both of them. With the only caveat that the containers need to be of the same type, okay? So for example, if we do this one on the left here, we have two strings. First string is 1, 2, 3, and the second string is 4, 5, 6. If we use the plus, the result is that it joins the two of them into one single string, like this. If we use numbers, the same idea, the same thing happens. In this first case, we have a list A that includes numbers 12, 17, and 18, and a list B that includes numbers 19 and 20. And so if we use this plus operation to join them together, if I say A plus B, it creates a new container that is a combination of the two. Okay, and the order is important because A plus B is not going to be the same as B plus A. Okay, if I do B plus A, then 19 and 20 will be the first two elements on the list. So the order is important, okay? So in this case, A plus B is not equal to B plus A when you use concatenation, okay? Okay, the other action that we can use is repetition. String, tuple, and list data types can be repeated using the asterisk operation. And so if we have a container, asterisk, and a number, then the container is going to copy as many times as the asterisk indicates. For example, if I have a string that has yes, no, and I use asterisk 5, it's going to repeat the information 5 times. So as you can see here, he has yes, no 5 times repeated. Same with numbers or lists, right? For example, if we go back to our original nums, if I say nums times 2, if you will, it basically replicates the information twice, right? So you can see here. The other action that we can do with containers is S containers, is membership. All containers can be checked for whether they contain a certain item as an element using the in or the not in operations, okay? The in or the not in operation. So for example, if I'm looking for a certain item in a container, I can search using this operation, or I can also look the other way around and say, well, is the item not in the container? Okay. In either case, the result is a Boolean operation. So the result of using in or not in will either be a true or false result. So a quick example here, going back to our nums again, right? Nums list. And let's say, for example, I say, well, is, according to notation, is this item, right, is 22 in nums, 22 in nums? Well, the answer is going to be false because 22 is not included in nums, okay? On the other hand, if I write the statement 40 in nums, well, 40 is in nums, so the answer or the result will be true. If I use the not in, then you know, I can use it in this way also, say, well, 22 is not in nums, and it's true. 22 is not in nums, so the result will be true. Another example, if I say 50 not in nums, well, the result is going to be false because 50 is in nums. Okay, so you see the difference here, right, between using in or not in. It's like using positive logic or negative logic, depending on what you're looking for. Okay, some other useful operations with strings. String creation, for example, in addition to using quotes for string creation, the str function can be used to create a string from its argument. For example, if I just want to create a string from within an argument, in this case, the argument is 4, this basically makes that 4 into a string, right? If I want to make a number into a string, it's very easy. I just type str in parentheses, whatever number I want to make it into a string, and it converts that into a string. In many cases, that's useful if you want to display information. Numbering information as strings is a very quick way of doing that. Also, for strings, concatenation, repetition, and membership is the same thing as we saw before, right? We just saw that example previously, but with strings, and specifically, it's very easy, very easy to use and implement, right? And we did this also in one of the first lessons in Python, right? So that we can see how this is used. However, we had not introduced the use of in at that time. But under that context, if we look at this first command here, the result of that command is that it's joining this four strings programming with Python is and fun into one single string, right? And that's what you see here. So if I say, and if I want to replicate again parts of a string, I can say, for instance, here, really fun 10 times, it'll write or it'll display or it'll save really fun 10 times in this case. And just as we did a few minutes ago, if I want to find out if something is in part of a string, for example, I can say, well, fun in Python, well, the answer is false because it's not part of this string here. But if on the other hand I said on in Python, then it's going to be true because Python includes the string on. Okay. But again, this is in the context of other useful operations for strings, right? We can also evaluate a string. If you have a string that is an expression describing some computation, you can use the eval, E-V-A-L function to evaluate the computation and get the result. So if I have S, which is a string, and is defined as 3 plus 4, if I do eval S, it'll give me the result. Because a computation, which in many cases is useful also. We can also delete and insert information from or to strings. And since strings are immutable, this is not possible, right, by itself. Because the only way is to create a new string, making use of slicing and concatenations. So then replacing the new create a string in the same place of the former one. For example, in this case, let's say I want to try to replace. I have a string that contains the. I have a variable that contains the string Python, and I want to replace the first letter. Okay, I want to replace P by S. So if I try to do that directly using indexing, as you can see here, right, it'll make kind of sense, right? I say, well, A0, which is the first index, so the first element here is P, make or put S in that location, right? Well, the result of performing that operation is that I'm going to get an error, okay? Because of what we said before, strings are immutable. Once they create it, I cannot change it by indexing like that. So I gotta go around it in order to do it. And it's not that you cannot do it, but you have to go around in another way of doing it. So for example, to change it, I can implement this statement. And if you notice here, this first index here, this statement here, A bracket 1 column, simply means that it'll contain this part of the statement says that it'll have all the elements in string starting at index 1, right? Index 1 will be everything here but the letter P, right? It'll include all of the letters except for letter P because I'll start at index 1. So in what I'm saying is I'm extracting, right, slicing, if you will, from Python, I'm extracting all the letters except for P. And I'm going to use concatenation to add S to this result. So what that means again is that this includes this string without the P, but this concatenation will add S as the first letter. And so B now, which is the new variable, will include, what I wanted in the first place, which was to replace P by the letter S. But you see what I had to do, right? Because I cannot do that directly through indexing because of the strings being immutable. I cannot change it directly using indexing. I have to go this way around. Okay. All right. Some other useful operations with lists and tuples. One of them is deletion from lists. And as far as deletion is concerned, you can use two methods. You can assign an empty list to the slice that you want to remove. For example, this is the original list, and I want to, from elements or index 1 through 5, right? Which in this case will be 0, 1, 2, 3, 4, 5, right? I want to put an empty content, right, in those locations. So if I do print L, right, from 1 through 5, then I have 0. This is 0, 1, 2, 3, 4. Remember, 5 is not going to be included, right? So I'll go from 1, 2, 3, 4. So that means that this statement here places an empty or deletes rather the elements on the list from 1 through 5. With 5 being the stopping, I have to move forward over to the left one time. So it replaces anything in between 111 and 666 by nothing. It deletes the elements in between those two first and last element, right? You see that here. So that's one way of doing it, using the empty list. There's also another command that is specifically used for that. It's called the del command or the del function. And it does the same thing. So if I want to remove the elements in the index 1 through 5, 5 being the stopping point, again, remember the 0, 1, 2, 3, 4, 5. So this will not include that element. This is just telling me that that's going to be the stopping point, but it will include the element before 666, which is 555. So this statement here, delete DLL1 column 5, deletes the elements in between 111 and 666. And that's what you see here at the end. All right. So this is a good stopping point, and I'll see you in the next lecture.